Welcome to my classroom. Students and colleagues, keeping in mind the demand of many students from many countries, I decided to include the lectures from other branches of soil science. For example, soil fertility, soil chemistry, maybe soil microbiology. Of course, soil physics is there. So keeping this in mind, I have changed the name of my channel. Instead of soil physics class, now it will be soil science class. So with this, I should say decision, I started the topic soil genesis and classification, and in today's lecture we will discuss about the concept of pedology and edaphology. Basically, if we see the domain of soil science, so domain of soil science falls under two headings. One is pedology, another is edaphology. Pedology and edaphology, or better I should say pedological approach. Pedological approach, edaphological approach. Now, pedology, in fact, it deals with this approach, deals with the study of origin of soil, its formation, its genesis, its classification. So we study this from the point of that how soils are formed. So we are not concerned that how these affect on the crop, or how these affect the plant which is growing in this particular soil. So pedology, it studies the origin, formation, or you better call it as genesis, that how soils are developed, then characteristics, and classification of soils. And yes, this pedological approach, this is important for engineers, this is important for the people who are serving, who are related to agriculture. Yes, it is important for both the engineers as well as agriculturists. Then edaphological, and here I will better say the word pedology comes from the Greek word pedon, and pedon means soil. Similarly, edaphology. Now, edaphology, in contrast to pedology, in pedology our concern is only with the origin, the formation, and the classification of soils, irrespective of their impact on plant growth. But here in pedology, we study the impact of soil on the growth of plants. So here we are more concerned about that this particular crop, this yields better in this particular soil or best in this particular soil. So based on, like we say, black cotton soils, so that means cotton thrives well in such type of soils. Or paddy soils, we say that okay, paddy thrives best in fine textured soils. So this is how we study the soil. Again, it is the study of soil. Edaphology, it is the study of soil from plant growth point of view. So here we treat the soil as a medium of plant growth. medium for growth of plants. So that's why in this case we are more concerned about the properties of the soil which affect plant growth. So here we are concerned about the properties of the soil with respect to its classification, that how, if this is the formation of soil, if this is the process of soil formation, we expect this type of soil to be there, and if we have different types of soils, we can classify on different on the basis of their properties. But here we study the properties of soil in relation to plant growth. For example, if we study that what is the pH of the soil, so that means here we are concerned about the pH of the soil, that whether this pH is suitable for the crop which I am going to grow in that particular soil. So I hope that now the concept of pedology and edaphology is clear to you. Again I say, pedology concerns with the origin of soil, type of soil. Edaphology is concerned with soil as a medium for plant growth. How the plants thrive best in such type of soils. Now, if we see in general, that origin of soil, just to look at that how soils originate or develop. So better I should say development of soil. So you might have studied in your earlier classes at the school level that earlier when this earth was very hot, it was basically molten magma. So initially the soil was a molten magma, and slowly this molten magma, it started cooling. So there was cooling and crystallization. Of magma. It resulted in the formation of igneous rocks. Then igneous rocks, some of these gave birth to two type of rocks. One is sedimentary rocks. So why I say that these igneous rocks, they gave birth to sedimentary rocks? Because basically when these igneous rocks were formed, slowly with the different processes, chemical, physical, biological, these rocks, they get weathered. Weathering means broken up and changes in that, and ultimately most of the material it got eroded along with the rain, run of water, and then somewhere these were deposited as sediments, and again these were known as sedimentary rocks. And ultimately, rather I should say, instead of this, of course both, some igneous rocks they got metamorphized. Metamorphosis means changes, physical changes, chemical changes. So here, because of the changes in sedimentary rocks and changes in igneous rocks, we got another type of rocks, that is metamorphic rocks. So got my point. First it was molten magma. Due to cooling and crystallization of magma, igneous rocks were formed, and due to weathering changes, I should say better here, weathering. So weathering means breakdown of rocks due to different factors, we got sedimentary rocks. And then again, with some changes in time, chemical changes, physical changes, biological changes, and both igneous as well as sedimentary rocks, we got metamorphic rocks. So this is how the rocks were formed. And then again, because of the weathering process, because the weathering process is very continuous process and it's a long term process. We cannot say that okay, weathering will result overnight. It may take thousands of years, it may take maybe millions of years, but it depends upon again the favorable weather conditions, favorable physical conditions, biological conditions, chemical conditions. So because of such type of conditions or weathering processes, we will study these weathering processes in our subsequent lectures. So due to this weathering, continuous weathering, I should say continuous weathering, these rocks, these turned into, I should say, parent material. Parent material means now these were not in the form of rocks, these were weathered material. It could be broken, it could be smaller, bigger in size, mixture of different sizes of the particles, which we call as parent material. And this basically, if you ask me what is this parent material, this is state of soil at the time of zero formation of soil. So here it is zero formation of soil. Though it's a parent material, parent means mother, father, it's a parent material for the formation of soils. But here when we say the parent material is formed, that means soil was not formed, it was parent material. Now how this parent material with the time it gets turned into soil. So what happens that because of soil factors, because of soil forming factors, plus soil processes, soil forming processes, this parent material gets converted into the soil. Now, what are the soil forming factors? Soil forming factors, these set the stage for operation of the processes of soil. How the stage is set? Because if you say some soil forming process has to take place, it should have some favorable conditions. For example, favorable temperature conditions, so that will be factor. Favorable moisture conditions, that will be another factor. Type of slope, degree of slope, that will be. So these are factors which create a situation, which create a scene for the soil forming processes to take place, for soil forming processes to happen. So different soil forming processes, then they act on this parent material in the presence of soil forming factors, and ultimately these soil forming factors and processes, these influence the soil properties. Even from the same parent material, due to different soil forming processes, due to different soil forming factors, you may have different types of soils, different properties of soils. So this is how from molten magma you get the formation of soil. But I should say from this process to this process, even from parent material to soil, it's a very long term process. It takes thousands, lakhs, millions of years, depending upon the factors, depending upon the favorable factors which may be favorable for a certain type of soil forming processes to act. So if this is how the soils are developed, then how should we define the soil now? So keeping this in mind, this whatever development process I told you, keeping this in mind, the geologists during early times, they simply said that soil is the weathered product of rocks. weathered product of rocks. And here when I say weathered product of rocks, the simple example is what you are seeing today in the Himalayas. The rocks, they are kind of landslides. Why landslides happen? If it's a solid rock, why landslide happens? Because then there are certain physical factors, like you have temperature, you have pressure, you have moisture, you have rainfall. But then you will ask me this question, that how landslide happens immediately. Now the question is, we have disturbed, we are making roads and bridges and tunnels, so we disturb those soils, we hasten the process of weathering. And if this process would have taken 10,000 years, perhaps it may take within 10 or 20 or 30 years. So that's why, because of the disturbance of the landscape, now this weathering process has been shortened. You better call it as mass movement. Mass movement is one type of soil erosion. So if I say soil gets eroded, if I say what is the difference between weathering and erosion? So weathering is very slow process, erosion is very fast process. So now the weathering has been, because of the human activities, because of the anthropogenic activities, this weathering process has been hastened, resulting in landslides, mud flows. This is becoming more common. Mud flows. Why the mud is coming down? Because of the hastening of weathering process. So this is how the geologists they initially defined. They said soil is the weathered product of rocks. Yes, fine. But then a Russian scientist called, his name was V.V. Dokuchev. V.V. Dokuchev. Dokuch. I should better check the spellings. AEV. AEV. Dokuchev is known as father of soil. Very common name with soil scientists. He first defined the soil. He said no, soil is basically a distinct natural body. A distinct natural body which has having definite genesis. That means every type of soil has been formed under certain conditions. The process of formation of different type of soils is different. It has a definite genesis process, and ultimately it's a natural body. It's a resource. That's why when we say that the natural resources, what are the natural resources out of different natural resources, or major three natural resources, we call air, water, and then soil. So soil itself is a resource. It's a distinct entity. So here I should say real morphology. Because if you look at the soil, okay, you say this is a weathered product of fine. But what is below the soil? It has a real morphology. It has some space for air, space for water, microorganisms, macroorganisms. They live in burrows, they live in small. Even the organic matter which is bound in by the mineral particles to form an aggregation. So real morphology of the soil lies below it. And that's why our society doesn't realize what the soil is. And some people say that soil is basically a living component. It's a living body. If you take a handful of soil, it may contain millions of microorganisms, and many of those microorganisms, they are beneficial. They convert the mineral form of nutrients into organic form of nutrients into mineral form of nutrients. And similarly, whatever fertilizers we apply in the soil, for example nitrogen, we apply nitrogen as urea, and that urea is basically the amide group. So amide is converted into ammonical nitrogen. and ammonical is converted into nitrate nitrogen, and nitrate nitrogen is basically taken up by many of the crop plants, all of the crop plants except rice crop. It relishes ammonical nitrogen because of reduced conditions prevalent in the soil. Now the question is how this amide is converted into ammonical form of nitrogen, and how this ammonical form of nitrogen is converted into nitrate form of nitrogen. That is with the help of microorganisms, bacteria, ammonifying bacteria, nitrifying bacteria. That's why soil itself is an entity. It's a laboratory. It's a factory. Better I should say it's a factory. So it creates the nutrient, it forms the nutrient, then organic matter which comes into the soil. The God has given us a natural cycle, carbon cycle. So whatever grows out of the soil, it should come back into the soil, then gets decomposed by these microorganisms, and that organic matter, it is a food for microorganisms, and in turn microorganisms, they help us in converting the organic form of nutrients into mineral form of nutrients, and in the form which are taken up by the crop plants. So you see, so it's a beautiful type of resource and living resource, and very heterogeneous also. It's very heterogeneous. It's not that okay, you have one how you see the soil. If it's a sandy soil at the top, you never know that at some depth it may be clay soil, or some there could be some higher organic matter, there could be some concretion, there could be some hard layer at some point. So it's such a heterogeneous. That's why it's very difficult. People try many type of classifications have been given. Some said black soil, some said clay soils, some said alluvial soils. So this is how the people earlier people, they classified the soils, but ultimately we came out with a seventh approximation, that's they call as taxonomy, soil taxonomy. So that was accepted world over as the classification of the soils. So this is how the soil has been defined. So again, now coming to pedology and edaphology as two sciences. As I said earlier, that was approach, pedological approach and edaphological approach. So pedology basically, it is the study of soil with respect to its origin, genesis, classification, etc. And this pedology, pedon, it word came from the Greek word pedon, and here pedon means, as I said, means soil or earth. Many people call it as earth, but better you call it as soil. So pedon means soil. So study of soil with respect to its origin, genesis, classification, and even I should say characteristics. So this is important, as I said, for engineers, town planners, important for, because earlier even nowadays also the engineers, particularly the civil engineers, when they have to prepare a road, when they have to make a tunnel or having some bridges and all that, so they check the soil for its capability, that how compact it is, how it can be compacted. So they see all the characteristics. Similarly, town planners also. The planners, when they plan the town, so they see the soil, type of soil it has, and of course for agriculturists. If I'm a soil scientist and I'm an agriculturist, so I need to know that what type of soil it is. what are its characteristics, how these type of soils have been formed, how I can classify it. So that's important for me, so that I should apply this pedology in edaphology. Okay, so second is edaphology. So again, edaphology is the study of soil from, as I said, standpoint of plant growth, study of soil with respect to plant growth. Here we study physical, chemical and biological properties with respect to their role on, with respect to impact on plant growth. But when you study these properties, you should have an idea about the pedology. So again, this is mainly for important for agriculturists, and the word edaphology means ground. So edaphos. So this means again ground. So why they said ground? Because so ground is different from the word this soil, because ground contains the vegetation growing on it, also the slope of the land. So that comes that's in addition to soil. So when I say edaphology, it means soil plus air, water, then plus the vegetation growing on it, landscape also. So that's all edaphology. Then some pedological concepts. For example, land and soil. What is the difference between land and soil? Generally, for a layman, he said land and soil, it is one and the same thing. But no, actually it's not. So when you say land and soil, it means land is a broader entity. How it's broader? That is, apart from soil, we include air, we include water, we include even organisms. Organisms means plant, animals, plants, either above the soil or below the soil. And even we include rocks and parent material, plus rocks plus parent material. So you got my point? So basically, when we say land and soil, soil is one component of land. Otherwise, land includes soil, air, water, organisms below the land, below the surface or above the surface. Within the soil, within within the land or above the land. And then soil. So this was about land. So I should better write over here land, and then soil. Soil is simply the smaller basic that's part of continuum. It's a smaller unit of land. And it's part of the continuum. And what is this continuum? Continuum is, parent material below, then soil, plus you have air in it, plus water, then here you may have soil, parent material, then soil, then vegetation which is growing about. So this soil is a unit of this continuum, whole continuum, and that continuum is called land. So better we call this as soil is heterogeneous mixture of organic and mineral materials. Mineral materials generally come from the parent material. Organic materials are either added at the surface of the soil, then decomposition starts, maybe upper layer of the soil, plus the root biomass, the dead roots of the plants. Plants could be crop plants, tree plants, so that when the plant dies or when we harvest the crop, the roots they also die and they remain within the soil. They become the organic materials, and this mixture of organic and inorganic or mineral material, we call this as soil. And ultimately this soil is here, it acts as medium for plant growth. Then another pedological concept is pedon. So I said that it's a Greek word which came from, which means, Greek word, pedon means soil. So pedon, and then we have polypedons. So first of all, pedon, as I said, this is the small basic entity, because you should keep in mind that yes, it's soil. But the question is soil. So what soil? I am standing over here. This is my field. So if I look at the horizon, that what are different type of layers I classify. Okay, this pedon, this soil or piece of soil, this is say type A. Then in another field, again if it's type A, that will be another pedon. But on the other hand, you may have a altogether different pedon. Different pedon may be type B. So this, when I say pedon, that means it's a single entity with certain characteristics, distinct characteristics I should say, certain distinct characteristics. And now you will say that, okay, should I call this field a pedon? Should I see two fields a pedon? No. I should say it will depend upon, if you have so many pedons of like say 5 pedons, similar distinct characteristics or just a small difference, then we call this as a pedon. And it could be as small as 1 meter to as big as 1 square meter to as big as 10 square meter. So this is the range of the size of pedon. Got my point? Because you are not going to get a similar. If you study the horizon over here, within the same field, if you study the horizon, there could be some minor differences. But we say that the major distinct characteristics are similar. So you call it a pedon. So it could be 1 square meter, it could be as big as 100 square meter. But then if you say that you have more area, say 1000 square meter, then what you will call? Then it will be polypedon. Poly means many. Now it could be cluster of similar or dissimilar. Dissimilar pedons. You got my point? So It could be the minimum area 1 square meter with no upper limit, no upper specified limit, because when you say that similar or dissimilar pedons, then you may go miles and miles and you find that yes, pedons are there, until and unless you then have some water body, maybe you have some river, or you may have oceans. So that's why you cannot specify the upper limit. It could be infinite also. So, but the minimum should be, to qualify for a polypedon, 1 square kilometer, and this may contain 1 square kilometer may contain similar pedon, cluster of similar pedons, or cluster of similar pedons may be bounded on all sides by dissimilar pedons. So this is how you say. But then again, I should say, this pedon, you better call it as a profile. Profile is what? How we define the profile? I'll just come to this point. So it's just like a profile, that a cross section of the soil, and you say, okay, in a particular area you see 1 or 2 cross sections and see if the properties are similar, you call it a pedon. So now the question is, it's generally it's hexagonal in shape, plus it's a three-dimensional profile. 3 dimension means if this is, the depth, you have studied different layers of the soil, length, breadth, up to what length it is similar, up to what breadth it is similar, and then of course depth is there. That's why we call it as a 3D. But this is not 3D, this is simply an area of different type of similar pedons bound by different dissimilar pedons. I hope that I am able to make things clear. Now, as I said, profile. What is soil profile? So let us understand the soil profile. Basically, as I said, the real morphology of the soil, it lies below the ground. Looking at the surface, you cannot say that what type of soil it is. Simply you can say, okay, the texture of surface layer is this, or structure of surface layer is this. What is below the soil, you will have to put a vertical section of soil. So if I say that, if I make a 3D, like this. I'm very poor in drawing, but still trying to. So you may have some vegetation over here. Okay. So this is all vegetation. And you take a vertical section of the profile just to study that what is lying below the soil. How the soil is varying with depth. It may not vary also, it could be homogeneous, it could be heterogeneous. So it is the profile is vertical section of the soil where, so better I should write, vertical section of profile with distinct layers, and we call these distinct layers as horizons. This is very important, and these horizons, they could be generally these are there are some physical differences in the horizon. Even there could be some chemical differences. For example, the salinity level, it changes its color. Then even acidic or alkaline or whatever it is, then concretion, that's also irreversible aggregation formed by various chemicals, and that's why I say that this horizonization, this layering, it could be because of the physical components, it could be because of chemical as well as biological also. We will just see now. Now the question is that these soil horizons or layers, so better we should use the word soil horizons. These are of two types. One is genetic and another is what you call as diagnostic. Genetic horizons and diagnostic. Now genetic, as the word says, these only express the qualitative judgment, that is when the soils are formed, how that depends on the parent material. So this is the qualitative judgment. Qualitative judgment. Just looking at the soil, okay, its color is different, it could be because of this. Texture, you can feel the texture, you can see the color, you can see the effervescence that determines the presence of salts in it. You could see even the compaction level of the soil. So these are all qualitative judgment of the soil and qualitative judgment of the changes which have taken place. If this layer, one layer is different from layer 2, is different from layer 3, that means some changes have taken place in the soil. So by just looking at this or classifying different horizons, identifying different horizons, we just have a qualitative judgment of the changes which have taken place. On the other hand, the diagnostic horizon means if some change has taken place, now what is the dominant characteristic of this particular layer? What is the dominant characteristic of layer 2, layer 3? How that's going to affect the plant growth? So that is the we call that as diagnosis. That is quantitatively defined layers. Here, quantitatively defined layers. For example, here when we say sand silt clay, we cannot say how much sand, how much silt, or it is loamy sand. We just feel it. We say sandy, silty, clayey, loamy, like this. But here we have quantitative, that this much is sand, this much is silt, this much of clay. If it's compact, this is the bulk density of the soil. We call that as hard layer, subsurface compacted layer, something. So this is quantitatively defined layers for soil classification. We generally use these, diagnostic horizons for classifying our soils. But in this case, the genetic horizons, we don't use them for classifying the soils. That is just for our own sake. We just having a qualitative judgment, we can say whether this soil is suitable for this particular crop which I plan to grow in that particular soil. Now here we will be, for the time being, we will just study about the genetic horizons. We will discuss only the genetic horizons, and maybe these diagnostic horizons we may study at a later stage. Now these genetic horizons, again of three types. Genetic horizons. First is what you call as master horizons. That means we differentiate these layers and we name them. Horizons, ZO. And we name them as O, A, E, B, something like that. And then we have the transitional horizons. Transitional horizons. Because these are the horizons, it could be the two layers having some characteristics of layer 1, some characteristics of layer 2. So we named as say, if layer 1 is A, layer 2 is E, we call it as AE. It could be AB, it could be BE. This is how we define these. And third type is the subordinate distinction. Subordinate distinction of master horizons. So I will explain it because we will study now these one by one. I'll explain it later. Master horizons. Now, first of all, the master horizons. So here the first one is O horizon. O, basically the word or alphabet has been derived from organic matter. This is the uppermost layer. This could be the O horizon. O horizon. So O is derived from the word organic matter. Because most of the organic matter may be under natural conditions, even under the cultivated conditions, that falls, that is added through the surface. You have leaf later falling in the surface, so that some millimeters or centimeter that may get mixed up with the organic, and always the surface layer will be rich in organic matter. It will be rich in humus, because humus is the decomposed form, end product of organic matter. Not exactly the end product, but it is the most stable part of the organic matter. So this layer, the thickness of this layer, it will depend upon, if you go to the forest land, you have huge litter fall on the surface of the soil. So this O horizon could be thicker in such type of soils than in your cultivated lands. Similarly, even grasslands may have thicker O horizon than in cultivated lands. So this is formed by organic matter, be it the surface. It could be, Now the question is it always at the surface? Could be below the surface also. You will be surprised, because as I said, the root biomass that adds organic matter in the lower layers also. So whenever there is concentration of decomposed organic matter or humus at some depth, you can also call it as O horizon. And this O horizon, it is formed by illuviation, illuviation, illuviation process. Illuviation means movement of some substance from upper layer to lower layer through the pore spaces. That is called illuviation. So if you have this O horizon at its subsurface depth, it could be due to the process of illuviation of organic materials into mineral subsoil. But then you won't call it as not O horizon. So O horizon could be at on the surface or now you will say that if it is not, when it's formed through illuviation process, then we won't call it a O horizon. Then your question should be that then O horizon should always be at the surface. Why should be at the depth we call it as O horizon? If I'm saying that's illuviation process, that doesn't qualify the horizon to be O horizon. So in that case, I will say, for example, the best example now in this part of Indo-Gangetic plains in India, what happened, we have a lot of floods, and of course there was well-defined organic matter at the top. So then, because of the floods, lot of sediments in the runoff water, flood water, those sediments, they got deposited to the extent of even 2 to 3 feet. So that means now a O horizon, it got buried up to 2 or 3 feet. and you have then sand or silt or different layers at the top, what I expect is that the sand should be below, then silt, and then clay, because of differential settling, So then that will be O horizon, which O horizon earlier at the surface got buried, but that which is formed by elevation or due to concentration of the stable form of organic matter, that is humus, we would call that O horizon. Is that clear? Okay, good. Then A horizon. Next layer, this horizon is below O horizon. Now, how we differentiate this? This is the mineral horizon, which is formed below O horizon, and this is of course mineral, because O was organic. This is mineral horizon, and this formed because O horizon. So if I say, okay, this is here A. Now, of course, it is mineral horizon, but then because it is below the organic horizon, so we expect that there could be some elevation of organic materials or organic matter into this layer. So it will be mixture of mineral fractions and organic matter. So due to elevation of organic matter, so it becomes a mixture. So this is its characteristics, and then its properties, they are the result of cultivation. Properties are due to cultivation, if it's agriculture land, or it could be pasturing, it's a grazing land, or any type of disturbance. You could have say a road, a horizon below the road, a horizon below some other land use. So if it's agriculture land, because of cultivation, so when you cultivate the soil, basically you are mixing the top layer, then you are mixing the, so of course even then you have O horizon, you have then A horizon, which has some mixture of organic material because of elevation process. After this, we have the third one, what we call as E horizon. Now word E, you will be surprised that why not C, why E? So here E comes from the word elevation, E-L-U-V-I-A-T-I-O-N. Elevation means movement of any substance from the horizon, one horizon, to the layer 2 horizon. So when something moves out, we call it as elevation. Something moves in, we call it as elevation. So that's why we use word E over here. So this is your third horizon, what we call as E. So I will distinguish like this. So this is your E horizon. So again, this is a mineral horizon. And main feature is it has what has moved out. So it has loss of silicates, iron, aluminium, etc. I should say yes, or some combination of these. So then you have the concentration of sands and silt particles. So I said that silicates are basically the silicate clays. So clay gets elevated, it moves out of this horizon, then iron moves out of this horizon, aluminium becomes, because due to solubilization these move down, that's why we call this as elevated horizon. So this is how it gets differentiated. And then below it we have a B horizon. B. Now B is below E, so that means this horizon should be rich in whatever has been lost from E horizon. So it should have silicates, iron, aluminium. So what I should say, yes, some combination. Then below B horizon, it will be rich. It is again a mineral horizon. Yes, of course, mineral horizon, which is rich in due to accumulation of clay, iron, aluminium, carbonates, gypsum, because these are, low, some color differentiation will be there. I'm not going to discuss color differentiation over here, because we have not I have not delivered a lecture on soil color. So if I talk in terms of technical terms of soil color, it will not be useful to you. You can study it in the notes. Then later when I discuss soil color chapter, I'll be explaining what is value, hue, chroma and all that. So this is then layer of accumulation or eluviation. So whatever got elevated, it got deposited in this B horizon. After B, we have C horizon. C horizon is generally, you can say, the parent material. This is unconsolidated rock material, what we call as parent material. And above this, the soil is there. So this is how, with the time, this parent material gets weathered because of the chemicals or physical processes or biological processes. So this goes on slowly and slowly, very slow process, it goes and converted into soil. And this could be, they may not have the, I should not say that if it came from sedimentary rock and it should have legacy with the parent material, no, with that parent, because sometimes it could be translocated from one place to another and something like that. So you cannot say that whether it developed from igneous rocks or sedimentary or metamorphic. So even you may have some, these parent materials developed on glaciers also. So ultimately it's unconsolidated matter, whether it's from igneous rocks or metamorphic rocks or sedimentary rocks, it is unconsolidated matter which slowly gets converted into soils. So these are the major, genetic horizons, and then we have some more horizons. R horizon. What is R horizon then? R horizon is, this is bedrock. After this, now it's not the unconsolidated. So this is R horizon, what we call as bedrock. So this is now consolidated rock material. Because it's not that, because I told you in the beginning that soil it developed from the rocks. So some portion of upper portion of the rock it got dismantled, it got unconsolidated, and then slowly converted into soil. And then below some portion remains consolidated, what we call as bedrock, such as it could be granite, because this portion is generally more stable than the parent material. Quartzite, limestone, quartzite, then limestone. Of course, these are the minerals from which the rocks, from where this R horizon came, that depends upon, and even sandstone also. Then we have L horizon again. Now these are L horizon. Now the horizons which I am going to discuss are not so commonly found. You can't find in the books, but now people have given these horizons also. L horizon. L horizon basically is, it includes both the mineral, the organic and mineral materials that are deposited in water by precipitation. Mineral and organic materials deposited by precipitation. When I say precipitation, it means runoff water also, which comes from, or even algae precipitation, then algae. Sometimes you see if the soil is abundant, no crop is growing on it, so then some water accumulates, algal formation is there. So because of this, that layer is created. You call that as L horizon. It could be by precipitation also, algae, or even diatoms also. So sedimentary peak, this layer is formed in histosols, particularly in histosols. Histosols are generally the organic soils. So wherever this layer is formed, you call it as L layer. So we cannot say that it has some definite location. After L layer, you have another layer we call as M layer. Again, this is the layer, this is root limiting subsurface layer. For example, you have, of course, horizon is there. Then this horizon, or any part of the two horizons, it could be having very high bulk density, it could be compact, it could restrict the growth of roots. So you can call it as root restricting layers. Again, it is, of course, it is subsoil, present at the subsoil. It could be at, generally it is at the depth below the plow layer. Plow layer means, generally plow layer is 0 to 15 centimeter. Below plow layer, you may have compaction, and you call this as root restricting layer. Then this could be horizontally oriented, even not necessarily compacted. It could be, some type of geotextile liners, and it could be even asphalt, concrete. But I should say that this type of layer you can find in construction soils, because when you are constructing something, construction soils, not exactly on this portion of the soil, when you are constructing a house or a building or anything else, then the soil adjoining that, they may contain some, the polythene at some depth, they may contain some asphalt, they may contain some even concrete, rock stone pieces, they may contain even some geotextiles which are used to protect the soil. Ultimately they get buried. So this is how, but of course, yes, you're right that this is because of the human interference due to anthropogenic, better call it as anthropogenic activities. So I hope you got this point. Construction soil, in my backyard of my house, when I plant some fruit tree, it doesn't grow well, and when I dig deep into the soil, I feel so many, some cloth pieces, some polythenes, some even cement bags also, you will be surprised. And this is how it restricts root growth, and these soils are not suitable for particularly the deep rooted tree crops. And then you have another layer. This is again very uncommon. I see, you won't find it everywhere in every book. You call it as W horizon or W layer. Now W comes from the word water. So this water layer within the soil or beneath the soil. So within or beneath the soil, it could be permanent frost, because in colder areas, temperate areas, the moisture present in some layer gets frosted, and it may form a horizon. We call it as W horizon. When it is permanent frost, we highlight it as WF, small f. And if it's a shallow water, then we won't call, not WF. If it is shallow water, so that means this is again permanent frost, water layer at deeper depths. And when it is at shallow water, we won't call it as W horizon or WF. Similarly, if it is ice or snow above the soil surface, ice or snow at soil surface, which is very common in temperate areas, again this will not be W horizon or WF. So this is how these are master layers, but these particularly L, M and W, these are not so commonly defined in the books, but just for the sake of knowledge, I thought it better to explain these layers also to you. And after master horizons, we have the transitional and combination horizons. This is again very interesting, that in the soil, when you go for soil survey, transitional and not or combination horizons. As the word says, transitional. Transitional means two layers have some in between some properties. These are dominated by this zone. Transitional is dominated by one horizon having certain properties of horizons above or below it. So for example, as I said, A, B, so that means A, and there could be some horizon instead of E, we could have some horizon which has characteristics similar to A and B. So we not exactly you can call it as A, not exactly you can call it as B, so better call it as AB. Similarly, then this. When I say AB, so it means more towards A than B. That means its properties are more towards like A than like B, but some properties are like B. That's why we call it as transitional. So this is transitional. And then what is combination? Combination horizon, here it is composed of two distinct parts. Now here it's not that properties are similar or mixed together. It is this horizon may have one part which is similar to A, another part similar to B. So two distinct parts, with recognizable properties. You can recognize that these properties recognizable, that these properties are for look like A, these properties look like B. So then you call it as A oblique B or B oblique say E, something like that. So here when we say A oblique B, then it means this horizon first, it has greater volume than this. So that's why we call this as combination horizon. So this is a layer, say over here you get A, some properties, some volume of A, some volume of B. Now you have already defined A over here. You cannot call this as B. So better call A oblique B. If A has higher volume than B. If B has higher volume than A, then you will call it as B oblique A. So this is how we define the transitional and combination. And lastly, as I said, the third group of horizons is that what we call as subordinate distinction. Third, subordinate, better not put third because I didn't put first or second. Subordinate what I say, distinction with master horizon. So this is not in itself that you are having a separate horizon or defining something separate horizon, but for example you have horizon A and this say it is B, O. Now we know that O is rich in organic materials. Okay, now O could be with organic materials which are highly decomposed. It could be the organic material intermediate decomposed. It could be the organic matter minimum decomposed. So then you are making a distinction. O, if it is highly, we call it as OA. If it is intermediate, we call it as OE. So this is your highly decomposed organic matter. So this is intermediate decomposed organic matter. And then if it is minimum decomposed, slightly decomposed, we call it as OI. So this is slightly decomposed organic matter. So this is how the science had. When I was in undergrad course, we were not taught beyond our horizon, but now I see the books with these type of horizons. So better I should say that after so many years I came to know that there is this type of horizonization also, that you are distinguishing the particular in different the profiles, whether O is highly decomposed or O is intermediate decomposed or O is not only this O, you can have some buried genetic horizon, which is buried. As I said that, okay, this O horizon comes over here, then it's buried. Then you will put OB, O small b. So this is buried O horizon. So very interesting, yeah. Because when you have to go to soil cell, if you say O at this depth, so instead of saying that OB, this means it is buried somewhere deep in soil. So this is how this is the concept of pedology, edaphology explained. So I have explained profile, edaphology, pedology, profile, its different horizons. I hope the things are clear. So we will continue, and I promise my students, because they have a complaint that you create a big gap in uploading my lectures. But now I promise that I'll be doing as better as I can. Thank you very much.